algorithm maxmin of I comma j comma max comma min is an example for divide and conquer method. Parameter description. Here there are 4 parameters: I, j, max and min. A of 1 to n is a global array. Array name is A and there are n elements. That means lower bound is 1 and upper bound is n. Parameters I and j are integers. 1 less than or equal to I. I should be greater than or equal to 1. And j less than or equal to n. 1 less than or equal to I, less than or equal to j, less than or equal to n. Values of I and j are in between 1 and n. Our aim is to set maximum and minimum value to the parameters max and min. Okay, that is from the n elements, a of 1 to n. From the n elements, find the maximum value and that is set to the parameter max. Okay, and find the smallest value from the n elements and set to the parameter min. We know that A of 1 to n is a global array. A of I to j is part of global array. Here there is an if loop. The condition is if I is equal to j. That is a situation of a small problem. Case of small problem. If I is equal to j, that means two index are same. Two array index are same. For example, I is equal to j is equal to 5. A of 5 and A of j are same. If I is equal to j, then there is only one element in the array, in the local array. Okay, part of array, part of global array A of 1 to n. I is equal to j means there is only one element in the array. Then smallest element is equal to largest element is equal to A of I. Okay, so set max is equal to min is equal to A of I. A case of smallest problem. Otherwise, if I is equal to j minus 1, I is equal to j minus 1. For example, if I is equal to 3, then j is 4. That is the situation of I is equal to j minus 1. That means there are two elements in the array. I is equal to j minus 1 means there are two elements in the array. That is another case of small problem in this algorithm. There are two elements in the array. Then there is a condition checking. We have to find which element is maximum, which is the smallest element. So condition is if A of I less than A of j, first element is less than second element, then set max equal to second element, min is equal to first element. Okay, if first element is less than second element is largest, then set max equal to second element fj and min is equal to first element. Otherwise, second element is less than first element. A of I is greater. If A of I is greater than A of j, then set max equal to parameter max equal to first element A of I and parameter min is equal to second element. Min is equal to A of j. Okay, these are the two cases of smallest problem in this algorithm. Only one element and there are two elements. If the local array contains only one element, that is the smallest case. Another case, there are two elements. If the array contains two elements, then another case of smallest problem. Now we have an example data set. There are 10 elements in the array. That is, A of 1 to 10 is a global array. Lower bound is 1 and upper bound is 10. There are 10 elements in the array. Our aim is to find the smallest element and the largest element from these 10 elements. Now the problem is large problem. Divide and conquer method means divide the problem into smaller and smaller subproblems. If the problem is small, then solve that subproblem and combine the result of all the subproblem. That is the result of that combined result is the result of main problem. Now the problem is large problem. If there is only one element, then we can say that the problem is small. If there are two elements, then we can say that problem is small. But now here there are 10 elements. So we can say the problem is a large problem. So we have to go to the second else part. Here P is not small. We have to divide P into sub problems. Here we use a tree data structure to explain this algorithm. So we create first a root node. Now we are in the main program. There are 4 parameters I, j, max and min. So we place the values of I and j in the root node. I is equal to 1, j is equal to 10. So we place values of I and j in the root node. We place max and min in later stages. Now the problem is large. So we go to the last part of else, last block of else. Find the mid value. Next, we have to find the mid value. Mid is equal to I plus j by 2. that is an integer division. Mid is equal to I plus j by 2. That means 1 plus 10 by 2, 11 by 2. Division is integer, so we will get mid is equal to 5. We know that this algorithm is a recursive algorithm. So each node represent a program, or each node represent an algorithm, one function. So each node keep 3 values relate to each function or each algorithm. That 3 values are I, j and mid. Now we are in main program. In the tree data structure, the root node represent main program. Now we find mid value. Next, our step is a recursive code. There are 2 recursive code. First recursive code is max min of I, mid, max, min. The first recursive code, we go to left subtree. Remember, in the first recursive code, we go to left subtree, and in the case of second recursive code, we go to right subtree in the tree data structure. Now we go to execute first recursive code, max min of I, mid, max, min. We know the values of I and mid. Have no idea about the values of max and min. We will set the values of max and min in later. So I is equal to 1, mid is equal to 5. We go to left subtree with parameters 1 and 5. Now we are in second recursive code, second program, second algorithm with values I is equal to 1 and j is equal to 5. No idea about values of max and min. We are in the beginning of second algorithm, second recursive code. The problem is not small. If I is equal to j or I is equal to j minus 1, then we can say that problem is small. But problem is not small. So we go to last block of errors. First we have to find the mid value. Mid is equal to I plus j by 2, 1 plus 5 by 2, 6 by 2 is equal to 3. Mid is equal to 3. Okay, we find the mid value. Mid is equal to 3. There are 3 values related to this algorithm. Second function, this function, that is I is equal to 1, j is equal to 5, and mid value of this algorithm is 3. That is represented in the first left subtree, first left node. Next we have to execute first recursive call of this function. So we pass I comma mid comma max comma min to the next recursive function. We know that values of I is equal to 1, mid is equal to 3. So pass 1 and 3 to the next function. Call next function, next recursive call. Okay, now we are in third function, second recursive call. We are at the beginning of third function, second recursive call with values I is equal to 1 and j is equal to 3 at the beginning of algorithm. That is easily represented in the tree data structure. Last left node. Values of I is equal to 1, j is equal to 3. At the beginning of the algorithm, it checks the problem is small or large. If I is equal to j, then we can say that the problem is small. I not equal to j, 1 not equal to 3. Second case of smallest problem, if I is equal to j minus 1, I not equal to j minus 1. If j is equal to 2, then we can say that problem is small. But now j is equal to 3, problem is not small, problem is a large problem. So we have to go to the last part of else block, last else block. Here it mentioned if p is not small, divide p into subproblems. So we have to find the mid value. Mid is equal to 1 plus 3 by 2, I plus j by 2. 1 plus 3 is equal to 4, 4 by 2 is equal to 2. Mid is equal to 2. There are 3 values related to this algorithm. I is equal to 1, j is equal to 3, mid is equal to 2. We have to keep these 3 values. Have no idea about max and min. Next we have to execute the first recursive call for this algorithm. We pass I, mid, max and min. Values of I is equal to 1, mid is equal to 2. Pass 1 and 2 to the next function. We call next recursive call with the values 1 and 2. Now we are in the beginning of this algorithm, this function, that is fourth function. We are in the beginning of fourth function or third recursive call with the values 1, 2. We know the values of I is equal to 1, j is equal to 2. Okay, we are in the beginning of fourth function. So first we check if I is equal to j. If I is equal to j, then we can say there is only one element in the array. I not equal to j. So we go to another case, next case. If I is equal to j minus 1, here condition is true. I is equal to j minus 1, 1 is equal to 2 minus 1. I is equal to j minus 1, condition is true. Then we have to find a of 1 or a of 2, which is greater. Okay, we have two elements, a of 1 and a of 2. Okay, please listen to the array, a of 1 and a of 2. A of 1 is 8 and a of 2 is 4. Okay, we have to find which is the largest element and which is the smallest element. Find the largest element and that is assigned to variable max. Find the smallest element which is assigned to variable min. Okay, here a of I less than a of j, a of 1 less than a of j, a of 2. Condition false. So we go to else part. Max equal to a of I, max equal to 8. Min is equal to a of j, min is equal to a of 2, a of 2 is 4. So in this function we got the values of max and min. Max equal to 8 and min is equal to 4. Now we does not go to the last else block, the algorithm exit and control returns back to its parent program, its parent algorithm. Its parent algorithm is node with mid value is equal to 2. Okay, now we are in that algorithm. We have three values for that algorithm. I is equal to 1, j is equal to 3 and mid is equal to 2. There are three values, I is equal to 1, j is equal to 3 and mid is equal to 2. On that algorithm, now next we have to execute the second recursive call. We complete the first recursive call in that algorithm. We have to execute the second recursive call. Second recursive call is max min of mid plus 1 comma j comma max 1 comma min 1. So we pass mid plus 1 3 comma 3, j is equal to 3, 3 comma 3 max 1 comma min 1 to the next function as argument. Next recursive call the next recursive call, next function with the values 3, 3 max 1 comma min 1. No idea about max 1 and min 1. We pass 3, 3 and 3 to the next function. Now we are in the node with 3, 3. That is I is equal to 3, j is equal to 3. No idea about max and min. Or we are in the algorithm with I is equal to 3, j is equal to 3, max comma min. We are in the beginning of the algorithm with I is equal to 3, j is equal to 3, max comma min. At the beginning, if I is equal to j, condition checking, if I is equal to j, then max equal to min is equal to a of I. Okay, here I is equal to j, condition true. I is equal to 3, j is equal to 3. That means there is only one element in the array. Okay, listen to the array. Index 3, I is equal to 3, j is equal to 3. Values in a of 3 is also 3. I is equal to 3, j is equal to 3. So max equal to min is equal to a of I. Okay, so max equal to assign 3 to max, also assign 3 to min. So we get max equal to 3 and min is equal to 3. Okay, 3 3 3 3, 4 threes. I is equal to 3, j is equal to 3, max equal to 3, min is equal to 3. We does not go to the last block, last else block. The algorithm completes this function, last recursive function completes. So exit from that function and the control returns back to its parent program, its parent algorithm. Okay, returns back to parent algorithm or returns back to control to its parent node with the mid value is equal to 2. Okay, now we are in node with the mid is equal to 2, or now we are in algorithm with the mid is equal to 2. That is, there are 3 values, I is equal to 1, j is equal to 3, mid is equal to 2. Okay, in that algorithm, listen to the else block. In that algorithm, we complete 2 recursive calls. First recursive call goes to the left subtree, and second recursive call goes to right subtree. We complete that 2 recursive calls. Okay, next we have to execute. Their comment is combine the solution. We have to combine the solution. We have to combine the 2 subtrees, left subtree and right subtree. Solution of, we have to combine the solution of 2 subtrees, or we have to find which max is greater. Max or max 1 is greater. Then we have to find min or min 1 is lesser. Okay, so condition, if max less than max 1, max less than max 1, here max is 8 and max 1 is 3. Okay, so condition false, there is no change. That is, max equal to 8, there is no change, max equal to 8. So assign 8 to variable max, that is 1 3 comma 8. Then last, if min greater than min 1, min is 4, min greater than min 1, min 4 greater than 3, condition true, then min is equal to min 1. Okay, so variable min is equal to min 1, variable min is equal to 3. So that is assigned to variable min. So we will get max equal to 8 and min is equal to 3. Okay, 1 3 8 3. We got 4 values, 1 3 8 3. That algorithm completes, that parent program completes. So exit from that parent program. Okay, that is, there are 3 functions, 3 algorithms completes. Last is the parent program with the mid is equal to 2, got max and min. Okay, so control goes to its parent program, its parent algorithm, that is node with mid is equal to 3, control returns back to parent program or parent algorithm, or in the tree structure node with mid is equal to 3. In that node or in that algorithm, first recursive call completes. Okay, so that is we already go to the left subtree. Next we have to execute second recursive code. We have three values: I is equal to 1, j is equal to 5, and mid is equal to 3. We have three values. So call the second recursive call with mid plus 1 comma j. Mid plus 1 is 4, j is 5. Call next function with the pass values 4 and 5. Okay, now we are in the algorithm with I is equal to 4, j is equal to 5. We are in the beginning of the algorithm with I is equal to 4, j is equal to 5. Okay, with the node, we are in the node with I is equal to 4, j is equal to 5. Okay, that is one of the smallest case. I is equal to j minus 1. Then we have to find, in if, we have to find which is greater. A of I is 10. Listen to the array. A of I means A of 4. A of 4 is 10. Then A of j is 5. A of j is 25. Okay, I is 4, j is 5. This algorithm checks in between I and j which is greater and which is smaller. A of 4, A of 5. Okay, if condition, if A of I less than A of j, A of I, A of 4 less than A of j, 10 less than 25, condition true. So max equal to A of j, max equal to 25, min is equal to 10. Assign 25 to variable max and assign 10 to variable min. Okay, 4, 5, 25, 10. That algorithm completes its execution. Control does not go to the last else block. Algorithm completes. That function, that recursive call completes its execution. Then control returns back to its parent program, its parent algorithm. That is, control returns back to algorithm with mid is equal to 3 or node with mid is equal to 3. In that node or in that algorithm, values of I is equal to 1, j is equal to 5, and we already find mid value is equal to 3. That algorithm's first recursive call already completed, and now its second recursive call also completes. Its next execution is combine the solution. Two recursive calls are completed. Next it execute, combine the solution. It has to complete which value is the maximum, max or max 1, which is maximum, min or in min 1, which is smallest value. In if checking, if max less than max 1, its max value is max is 8, max 1 is 25. So 25 is greater. So 25 assigned to variable max. Then next step, min greater than min 1. Min is 3, min 1 is 10. Min greater than min 1, condition false, so no change. Min is 3, it keeps its value. So in that node, values are I is equal to 1, j is equal to 5, mid is equal to 3, and new values max equal to 25 and min is equal to 3. And the algorithm terminates. Okay, 1, 5, 25, 3. We are in algorithm with I is equal to 1, j is equal to 5, max equal to 25, min is equal to 3. Okay, we know that A of 1 to n is a global array. Our aim is to find minimum value and maximum value from global array A of 1 to n. But in that particular node, in that particular algorithm, with I is equal to 1, j is equal to 3, we find the maximum value and minimum value between 1 and 5, A of I to j. A of I to j is local array. From A of 1 to 5, elements between 1 and 5, we find the maximum value. Here the maximum value is 25 from A of 1 to 5. And minimum value is 3 between or in the array A of 1 to 5. Okay, now we completes its execution, completes the execution of that algorithm with mid is equal to 3. So we returns back to its parent program. Its parent program is, or parent algorithm is, node with or algorithm with mid is equal to 5. Its parent program's values are I is equal to 1, j is equal to 10, and mid is equal to 3. There are 3 values. We keeps 3 values. Then its next execution is second recursive call. First recursive call is already completed. Then its next execution, the root node's next execution. First algorithm's next execution is max min of mid plus 1 comma j comma max 1 comma min 1. Second recursive call. So we go to right subtree with parameters mid plus 1, that is 6 comma j 10. Pass values 6 and 10 to the next function, that is 6 and 10s are assigned to I and j respectively. Okay, 6, 10. I is equal to 6, j is equal to 10. A new function call, new algorithm with the parameters I is equal to 6, j is equal to 10. Now the problem is not small. Our aim is to find maximum value and minimum value from a of 6 to 10, index 6 to 10. There are 5 elements: a of 6, a of 7, a of 8, a of 9, a of 10. That is 90, 60, 70, 11, 7. From these elements, we have to find the maximum value and the minimum value. Okay, the problem is not small, so we have to go to the last block, last else block. First we have to find mid value. Mid is equal to I plus j by 2, 6 plus 10 by 2, 16 by 2 is equal to 8. Mid is equal to 8. Okay, we find mid is equal to 8. In that algorithm, there are 3 values: I is equal to 6, j is equal to 10, mid is equal to 8. Next, we have to execute the first recursive call. In tree data structure, we go to left subtree. Max min of mid plus 1 comma j comma max 1 comma min 1. So go to left subtree with the parameters I comma mid 6 comma 8. Okay, 6 comma 8. Now we are in the beginning of a new function, a new recursive call with the values 6 and 8. I is equal to 6, j is equal to 8. We have to find the maximum value and the minimum value from a of 6 to 8. A of 6 is 90, a of 7 is 60, a of 8 is 70. From these 3 elements, 90, 60, 70, we have to find which is maximum value and which is minimum value. The problem is not small. Problem is a large problem. So we have to go to the else block, last else block. In the beginning, we find mid value. Mid is equal to 6 plus 8 by 2, 14 by 2. So mid is equal to 7. Okay, mid is equal to 7. I is equal to 6, j is equal to 8, mid is equal to 7. Next we have to execute the first recursive call. So we go to left subtree in the tree data structure. So call the function next recursive call with the parameters 6 and 7. Okay, 6, 7. Now we are in the beginning of a new recursive function, a new program with I is equal to 6, j is equal to 7. Okay, we know that when there are 2 elements, a of 6 and a of 7. There are 2 elements. From these 2 elements, we have to find which is maximum and which is small. That is, a of 6 is 90, a of 7 is 60. From these 2 elements, which is maximum? From 90 and 60, which is maximum? So in if a of I less than a of j, a of I is a of 6, 90 less than 60, condition false. So we go to else part. Max equal to a of I, max equal to 90, min is equal to 60. Okay, that is we assign 90 to max and 60 to min. Okay, 6, 7, 90, 60. We find the maximum and minimum value from a of 6 to 7 from those two elements, a of 6 to 7. 90 is the maximum value and 60 is the smallest value. So algorithm completes, that function completes its execution. So return back to its parent program. Its parent program is mid with a node with mid value is equal to 7, or algorithm with mid value is equal to 7. On that function, on that algorithm, its first recursive call is completed, then it executes its next recursive call, second recursive call. Its second recursive call go to right subtree with parameters mid plus 1, 8 comma j, 8 comma 8. Its arguments are 8 comma 8. Okay, 8. We are in the beginning of a new function, a new algorithm with parameters I is equal to 8 and j is equal to 8. Now the problem is small, that is here I is equal to j, I is equal to j is equal to 8. So we can say the problem is a very small problem. There is only one element, that is a of 8. Here max equal to min is equal to a of 8, that is 70. From one element we have to find maximum and minimum value. So maximum value is equal to minimum value is equal to 8. So we assign a of 8, that is 70 to the variable max and 70 to the variable min. Max equal to min is equal to a of 8, that is 70. Okay, 8, 70, 70. That function complete its execution. That algorithm completes its execution. That is, it does not go to the last else block. Algorithm completes. So this algorithm returns its control to its parent program, parent algorithm. Its parent algorithm is algorithm with mid is equal to 7, or in tree data structure, node with mid is equal to 7 is its parent node. Okay, in the case of that parent node, is two recursive calls are completed. Next, its execution is combine the solution. So it combined the two solutions of recursive calls, that is find which is maximum from 90 and 70. Find the maximum value and assign it to variable max. Okay, from 90 and 70, maximum value is 90, so assign 90 to variable max, and from 60 and 70, max 1 and min 1, sorry, min and min 1. Here minimum is 60, so assign 60 to variable min. Okay, 6, 8, 90, 60. That algorithm completes its execution. All statements are executed. That algorithm's execution completed. So control return back to its parent program. Control returns to its parent program, its parent algorithm. Its parent algorithm is algorithm with mid is equal to 8, or we can say returns to its parent node with the mid is equal to 8 in the tree data structure. Okay, here values are I is equal to 6, j is equal to 10, and mid is equal to 8. Okay, next from that parent algorithm, or from that node, its first recursive call is completed. That is, left subtree part is completed. Next we have to execute the right subtree. We have to go to right subtree, or we have to execute the next second recursive call with the parameters mid plus 1, that is 9, 10 as arguments. Pass 9 and 10 to the next recursive call. Okay, 9, 10. Now we are in the beginning of a new function with the parameters I is equal to 9, j is equal to 10. That is, we have to find the maximum and minimum value from two elements, a of 9 and a of 10. That is, find the maximum from 11 and 7. Maximum and minimum from 11 and 7. Now the problem is small. That is, there are two elements, I is equal to j minus 1. Okay, so find the maximum value, that is max equal to a of 9. Assign a of 9, that is 11 to variable max, and a of 10, 7 is the minimum, 7 to min 1. Okay, assign 11 to max 1 and assign 7 to min 1. Okay, 9, 10, 11, 7. I is equal to 9, j is equal to 10, max 1 is equal to 11, min 1 is equal to 7. The algorithm completes its execution, does not go to the last else block. Algorithm completes its execution and control returns back to its parent program. Its parent program is an algorithm with mid is equal to 8. Parent algorithm is an algorithm with mid is equal to 8, or in tree data structure, its parent node is node with mid is equal to 8. Here values of I is equal to 6, j is equal to 10, mid is equal to 8. In that parent nodes, two recursive calls are completed. Next it has to complete last two statement. Combine the solution. Find max and min. From 90 and 11, find the maximum value. That is, check 90 and 11, which is maximum. Here maximum value is 90. So assign 90 to variable max. And from 60 and 7, find which is minimum. That is, from min and min 1. Min is 60 and min 1 is 7. Find the minimum value. Here min 1 is minimum. So assign 7 to min. Okay, 6, 10, 97. Maximum is 90, minimum is 7. That algorithm, that function completes its execution. Then it returns back to its parent program. It is parent algorithm. That is the algorithm with mid is equal to 5. First main program. Algorithm with mid value is equal to 5. Or in the tree data structure, node with mid is equal to 5 is the parent program. Here I is equal to 1, j is equal to 10 and the mid is equal to 5. Its two recursive calls are completed. That is, left subtree part is completed and the right subtree part is completed. Its two recursive calls are completed. Next, it has to execute the last two statements. Combine the solution. That is, check max and max 1, min and min 1. Okay, here max is 25, max 1 is 90. Compare these two values and assign the greatest value. Greatest value is 90. That is assigned to variable max. Then last line, compare min and min 1. Here min is 3 and min 1 is 7. So assign the smallest value to min. Here the smallest value is 3. So assign 3 to min. Okay, 110, 93. The algorithm completes its execution. Also, all the sub functions are completed. All the recursive calls are completed. Algorithm completes. That is, listen to the row node. From the global array, a of 1 to 10. A of 1 to 10 is global array. Other arrays are, other sub functions are local. From a of 1 to 10, maximum value is 90 and the minimum value is 3. Okay, listen to each node. For example, listen node with mid is equal to 2. Here I is equal to 1, j is equal to 3. From a of 1 to 3, that is, there are 3 elements, 8, 4, 3. From those elements, find the maximum value. Maximum value is 8 and the minimum value is 3. Okay, listen to node with mid is equal to 3. From a of 1 to 5, a of 1 to 5, array index from 1 to 5. Here the largest value is 25, smallest value is 3. Listen to node with mid is equal to 8. A of 6 to 10. Array A of 6 to 10. Maximum value is 90 and the minimum value is 7. Node with mid is equal to 7. A of 6 to 8. From A of 6 to 8, maximum value is 90 and the minimum value is 60. That is same in the case of each and every node.